The official idea and definition of AI was first coined by J. McCartney in 1955 at the Dartmouth Conference. Of course, there was plenty of research work done on AI by others such as Alan Turing before this, but what they were working on was an undefined field before 1955. Okay, so here's what McCarthy proposed. Quote, "Every aspect of learning, or any other feature of intelligence, can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves." Translation. In essence, AI is a machine with the ability to solve problems that are usually done by us humans with our natural intelligence. A computer will demonstrate a form of intelligence when it learns how to improve itself at solving these problems. So now we have an understanding of AI and intelligence. To bring it together a bit and solidify the concept in your mind of what AI is, here's a few examples of AI. Machine learning, computer vision, natural language processing, robotics, pattern recognition, and knowledge management. What's machine learning then? Machine learning refers to algorithms that enable software to improve its performance over time as it obtains more data. This is programming by input-output examples rather than just coding. So that this makes more sense, let's use an example. A programmer would have no idea how to program a computer to recognize a dog, but he can create a program with a form of intelligence that can learn to do so. If he gives the program enough image data in the form of dogs and let it process and learn, when you give the program an image of a new dog that it's never seen before, it would be able to tell that it's a dog with relative ease.
And how can technology and intelligent connectivity help them solve real-world problems, like not having enough water, pollution, transportation, traffic, the ability to communicate and manage their overall network? And it all starts with just really understanding kind of the art of the possible, just changing the way that they think about their own departments. You're no longer the lighting department, you're the connectivity department, because that light pole needs to do more than just light. What if it had a small cell on it, solve density issues for a new up-and-coming area in a city? So now all of a sudden, the lighting department's working with the transportation department. The concept of being able to combine a lot of those different franchises into a single unit is something. If I was to design a city, it would be intelligent enough to basically interact with its citizens and the government at the same time. So to me, an intelligent or smart city isn't so much about the type of technology or the type of connectivity that's being used, but it is about the fact that you've got data and information that's being shared across departments, from department to department, as well as back to the citizens and then back again. So it's almost like a ever-circling system, and eventually that makes the whole system even more efficient and effective and sustainable too.
The development of autonomous cars is strongly linked to the need and the drive to enhance safety in vehicles. It turns out that people are pretty bad drivers. In 2013, over 1 million deaths occurred on the roads worldwide. This is the 8th leading cause of death globally and the number 1 cause of young people. Global losses due to road traffic injuries are estimated at over $500 billion. Human error accounts for around 90% of all vehicle crashes. The reasons? Poor lookout, excessive speed, inattention, wrong evasive action, internal distraction. Estimated that up to 15 times more people could fit on today's roads. Autonomous vehicles will therefore help decongest today's cities and also save people's time, as autonomous cars are able to safely drive much closer to each other. So, what are autonomous cars? The US Department of Transport allows for 5 different levels of autonomy. No autonomy. The car is assisting the driver by using safety systems such as ESP and ABS. 2 or more safety systems working together, such as adaptive cruise control combined with lane centering. The vehicle fully controls itself, only needing occasional input from the driver. Complete and full autonomy. The vehicle can drive itself under all circumstances and in all weather conditions. It only needs to know the destination. Example, latest version of the Google car, which has no steering wheel.
2.5 billion gigabytes of data generated each day are increasingly complex patterns to interpret, smarter decisions to be made, and innovative new discoveries to unlock. We need systems that behave and interact with us more intelligently to decode this data in all its forms, from pictures and videos posted on social media to real-time sensory information collected by satellites in space. Cognitive computing means enabling machines to interact with humans in a more natural way, learn at scale, and reason with purpose. Cognitive technology is key to drawing rational business conclusions from the right data, so you can implement solutions with confidence. You might trust social media as a source to analyse the customer experience at a hotel or restaurant, for example. But when treating a serious medical condition, you'd put evidence-based research first. By learning and evolving based on user feedback, past experiences and new data, cognitive systems can become experts in specific areas. In effect, they become the perfect assistant.
Our robots have a lot of sensors on them. They have vision and they have force sensing, and so they can operate in environments where people are.
Rodney Brooks, founder of Boston-based Rethink Robotics, is changing the way we think about robots in the workplace.
Baxter was our first robot. It's 2 arms, it's large. Sawyer, we learnt from Baxter. We made it much smaller.
With cameras, sensors, and enough intelligence to learn tasks within an hour, Sawyer is a collaborative robot designed to work safely alongside humans.
We've run out of low-cost labour in the world to do our manufacturing. So it has to be through tools that help workers be more productive.
At $29,000 a unit, Sawyer helps package products or check quality control. The idea started more than a decade ago.
I was in China a lot, getting the manufacturing running for the Roomba.
That's the robotic vacuum made by iRobot, a company he co-founded.
And I was starting to see that labour was getting shorter and shorter in 2004, 2005. The old days of infinite supply of labour was starting to change.
Rethink Robotics has raised $130 million in funding and is using its latest investment to expand globally.
Europe has become a major market for us very quickly, as has China. I think there's incredible potential to grow the cobot market.
According to Barclays, the cobot market could grow from just over $100 million last year to $3 billion by 2020.
Have you heard about big data? It's the latest rage. Everyone is talking about it. It's supposed to revolutionise loads of stuff like advertising, policing, the health sector, global development and humanitarian relief. And you know what? It's got some potential. But unchecked, it is posing some serious dangers, particularly, you guessed it, to your privacy. It all comes down, as always, to you and your marketplace value as data. Online, offline, every which way line, you just can't help producing the stuff. And there's a huge drive to collect it all because intelligence can be gleaned from it. In a sense, there's nothing new under the sun. Market and social research has always sought to help companies and governments map, understand and predict our behaviour. And until recently, there were laws that kept them on the straight and narrow. But big data comes along as this big idea, and suddenly they're collecting sets of data that are so, well, big in their breadth and depth that the field has changed entirely. This is the data that every company and government is now clamouring to collect. Because knowledge is power, and everybody's job becomes easier the more they know about everybody else. They may have asked permission to originally collect it for a stated purpose, but then it's very likely they started quietly using it for others. So think about your regular store, the one where you shop most often and use a loyalty card at. A company can take its customer database, extract and analyse information on the purchasing habits of customers, and cross-reference that dataset with increasingly available data on income, property ownership, age and other specific sets. They can then identify customers who will be most likely to respond to particular advertising. So this all comes down to predictive algorithms for marketing purposes. Searching, aggregating and cross-referencing in order to generate intelligence. Simple, right? Except, in cross-referencing datasets like this, big data analytics are putting together pieces of data that, in isolation, are seemingly innocuous, but in combination produce a detailed picture of troubling accuracy. For everyone. Across all transactions, all communications and all movements. This is intelligence gathering on entire societies, letting powerful institutions learn things about us and wider groups make decisions about us. In secret. Is this still okay with you? And here's another problem with big data. When the algorithms identify abnormal data in larger datasets, it can actively contribute to discrimination against specific groups or activities. Because that's something we need more of in the world, right? For example, a 2014 White House report on big data said that web searches involving black identifying names, for example Jermaine, were more likely to display ads with the word arrest in them than searches with white identifying names like Jeffrey. If you don't fit the mould, or you act out of the norm, or appear to be from an undesirable grouping, you will be placed into boxes that will be nearly impossible to escape from. Plain old error is another small problem with big data. Numerous data mining initiatives have been attempted and tried, resulting in tens of thousands of people being wrongly identified as terrorists. Other serious and ruinous error can happen, like having your driving licence mistakenly revoked, your benefits cancelled, electoral participation denied, even arrests made and being detained. And in fact, many of these problems are the result of the new roles algorithms play in law enforcement. As slashed budgets lead to increased staff cuts, automated systems have moved from acting as simple administrative tools to primary decision makers. Several cities across the US are using such tools to analyse crime statistics, map where crimes are more likely to occur, and allocate resources accordingly. Intelligence agencies want to mine metadata to understand behaviours of non-suspects in order to identify who should be a suspect. The fundamental misunderstanding is that data equals truth. It doesn't, and we shouldn't blindly believe that any and all tasks can be automated to begin with. When social infrastructure itself depends on an algorithm, and that algorithm can be wrong, unfit for purpose, or just simply biased, our lives are being seriously interfered with in an arbitrary fashion. Big data can be helpful, but it can be incredibly dangerous. And all this can be happening now to you and your data without you even knowing it. We need to open this up to public scrutiny. We need stronger privacy laws that allow us to control our own data. We need access and understanding on the scope of these algorithms, and we need to ensure that intelligence programs do not create even bigger problems in society, including through discrimination and exclusion. It's time to learn more about big data. Dig deeper by going to privacyinternational.org.
When you think of automation, you probably think of this: giant, custom-built, expensive, efficient, but really dumb robots blind to the world and their own work. They were a scary kind of automation, but they haven't taken over the world because they're only cost-effective in narrow situations. But they're the old kind of automation. This is the new kind. Meet Baxter. Unlike these things, which require skilled operators and technicians and millions of dollars, Baxter has vision and can learn what you want him to do by watching you do it, and he costs less than the average annual salary of a human worker. Unlike his older brothers, he isn't pre-programmed for one specific job. He can do whatever work is within the reach of his arms. Baxter is what might be thought of as a general-purpose robot, and general purpose is a big deal. Think computers. They too started out as highly custom and highly expensive, but when cheap-ish general-purpose computers appeared, they quickly became vital to everything. A general-purpose computer can just as easily calculate change, or assign seats on an airplane, or play a game, or do anything just by swapping its software. And this huge demand for computers of all kinds is what makes them both more powerful and cheaper every year. Baxter today is the computer of the 1980s. He's not the apex, but the beginning. Even if Baxter is slow, his hourly cost is pennies worth of electricity, while his meat-based competition costs minimum wage. A tenth the speed is still cost-effective when it's 100th the price. And while Baxter isn't as smart as some of the other things we will talk about, he's smart enough to take over many low-skilled jobs. And we've already seen how dumber robots than Baxter can replace jobs. In new supermarkets, what used to be 30 humans is now 1 human overseeing 30 cashier robots. Or take the hundreds of thousands of baristas employed worldwide. There's a barista robot coming for them. Sure, maybe your guy makes the double mocha whatever just perfect and you'd never trust anyone else, but millions of people don't care and just want a decent cup of coffee. Oh, and by the way, this robot is actually a giant network of robots that remembers who you are and how you like your coffee no matter where you are. Pretty convenient. We think of technological change as the fancy new expensive stuff, but the real change comes from last decade's stuff getting cheaper and faster. That's what's happening to robots now. And because their mechanical minds are capable of decision-making, they are out-competing humans for jobs in a way no pure mechanical muscle ever could. As mechanical muscles pushed horses out of the economy, mechanical minds will do the same to humans. Not immediately, not everywhere, but in large enough numbers and soon enough that it's going to be a huge problem if we're not prepared, and we're not prepared. You, like the second horse, may look at the state of technology now and think it can't possibly replace your job, but technology gets better, cheaper, and faster at a rate biology can't match. Just as the car was the beginning of the end for the horse, so now does the car show us the shape of things to come. Self-driving cars aren't the future. They're here and they work. Self-driving cars have traveled hundreds of thousands of miles up and down the California coast and through cities, all without human intervention. The question is not if they'll replace cars, but how quickly. They don't need to be perfect, they just need to be better than us. Human drivers, by the way, kill 40,000 people a year with cars just in the United States. Given that self-driving cars don't blink, don't text while driving, don't get sleepy or stupid, it's easy to see them being better than humans because they already are. Now, to describe self-driving cars as cars at all is like calling the first cars mechanical horses. Cars in all their forms are so much more than horses that using the name limits your thinking about what they can even do. Let's call self-driving cars what they really are. Autos, the solution to the transport objects from point A to point B problem. Traditional cars happen to be human-sized to transport humans, but tiny autos can work in warehouses and gigantic autos can work in pit mines. Moving stuff around is who knows how many jobs, but the transportation industry in the United States employs about 3 million people. Extrapolating worldwide, that's something like 70 million jobs at a minimum. These jobs are over. The usual argument is that the unions will prevent it, but history is filled with workers who fought technology that would replace them, and the workers always lose. Economics always wins, and there are huge incentives across wildly diverse industries to adopt autos. For many transportation companies, humans are about a third their total costs. That's just the straight salaries. Humans sleeping in their long-haul trucks cost time and money, accidents cost money, carelessness costs money. If you think insurance companies will be against it, guess what? Their perfect driver is one who pays their small premiums and never gets into an accident. The autos are coming, and they're the first place where most people will really see the robots changing society. But there are many other places in the economy where the same thing is happening, just less visibly. So it goes with autos, so it goes for everything. It's easy to look at autos and Baxters and think technology has always gotten rid of low-skilled jobs we don't want people doing anyway. They'll get more skilled and do better educated jobs like they've always done. Even ignoring the problem of pushing 100 million additional people through higher education, white-collar work is no safe haven either. If your job is sitting in front of a screen and typing and clicking, like maybe you're supposed to be doing right now, the bots are coming for you too, buddy. Software bots are both intangible and way faster and cheaper than physical robots. Given that white-collar workers are, from a company's perspective, both more expensive and more numerous, the incentive to automate their work is greater than low-skilled work. And that's just what automation engineers are for. These are skilled programmers whose entire job is to replace your job with a software bot. You may think even the world's smartest automation engineer could never make a bot to do your job, and you may be right, but the cutting edge of programming isn't super smart programmers writing bots, it's super smart programmers writing bots that teach themselves how to do things the programmer could never teach them to do. How that works is well beyond the scope of this video, but the bottom line is there are limited ways to show a bot a bunch of stuff to do, show the bot a bunch of correctly done stuff, and it can figure out how to do the job to be done. Even with just a goal and no knowledge of how to do it, the bots can still learn. Take the stock market, which in many ways is no longer a human endeavor. It's mostly bots that taught themselves to trade stocks, trading stocks with other bots that taught themselves. As a result, the floor of the New York Stock Exchange isn't filled with traders doing their day jobs anymore. It's largely a TV set. So bots have learned the market and bots have learned to write. If you've picked up a newspaper lately, you've probably already read a story written by a bot. There are companies that teach bots to write anything, sports stories, TPS reports, even say those quarterly reports that you write at work. Paperwork, decision-making, writing, a lot of human work falls into that category, and the demand for human mental labor in these areas is on the way down. But surely the professions are still safe from bots, yes? When you think lawyer, it's easy to think of trials, but the bulk of lawyering is actually drafting legal documents, predicting the likely outcome and impact of lawsuits, and something called discovery, which is where boxes of paperwork gets dumped on the lawyers and they need to find the pattern or the one out-of-place transaction among it all. This can be bot work. Discovery, in particular, is already not a human job in many law firms. Not because there isn't paperwork to go through, there's more of it than ever, but because clever research bots shift through millions of emails and memos and accounts in hours, not weeks, crushing human researchers in terms of not just cost and time, but most importantly, accuracy. Bots don't get sleepy reading through a million emails. But that's the simple stuff. IBM has a bot named Watson. You may have seen him on TV destroy humans at Jeopardy, but that was just a fun side project for him. Watson's day job is to be the best doctor in the world, to understand what people say in their own words and give back accurate diagnoses. He's already doing that at Sloan Kettering, giving guidance on lung cancer treatments. Just as autos don't need to be perfect, they just need to make fewer mistakes than humans, the same goes for doctor bots. Human doctors are by no means perfect. The frequency and severity of misdiagnoses are terrifying, and human doctors are severely limited in dealing with a human's complicated medical history. Understanding every drug and every drug's interaction with every other drug is beyond the scope of human knowability, especially when there are research robots whose whole job it is to test thousands of new drugs at a time. And human doctors can only improve through their own experiences. Doctor bots can learn from the experience of every doctor bot, can read the latest in medical research and keep track of everything that happens to all their patients worldwide and make correlations that would be impossible to find otherwise. Not all doctors will go away, but when the doctor bots are comparable to humans and they're only as far away as your phone, the need for general doctors will be less. So professionals, white-collar workers, and low-skill workers all have things to worry about from automation. But perhaps you are unfazed because you're a special creative snowflake. Well, guess what? You're not that special. Creativity may feel like magic, but it isn't. The brain is a complicated machine, perhaps the most complicated machine in the whole universe, but that hasn't stopped us from trying to simulate it. There is this notion that just as mechanical muscles allowed us to move into thinking jobs, that mechanical minds will allow us to move into creative work. But even if we assume the human mind is magically creative, it's not, but just for the sake of argument, artistic creativity isn't what the majority of jobs depend on. The number of writers and poets and directors and actors and artists who actually make a living doing their work is a tiny, tiny portion of the labor force. And given that these are professions dependent on popularity, they'll always be a very small portion of the population. There can't be such a thing as a poem and painting-based economy. Oh, by the way, this music in the background that you're listening to, it was written by a bot. Her name is Emily Howell, and she can write an infinite amount of new music all day for free. And people can't tell the difference between her and human composers when put to a blind test. Talking about artificial creativity gets weird fast. What does that even mean? But nonetheless, it's a developing field. People used to think that playing chess was a uniquely creative human skill that machines could never do, right up until the point they beat the best of us. And so it will go for all human talents. Right, this may have been a lot to take in, and you might want to reject it. It's easy to be cynical of the endless and idiotic predictions of futures that never are. So that's why it's important to emphasize again that this stuff isn't science fiction. The robots are here right now. There is a terrifying amount of working automation in labs and warehouses around the world. We have been through economic revolutions before, but the robot revolution is different. Horses aren't unemployed now because they got lazy as a species, they're unemployable. There's little work that a horse can do to pay for its housing and hay. And many bright, perfectly capable humans will find themselves the new horse, unemployable through no fault of their own. But if you still think new jobs will save us, here is one final point to consider. The US Census in 1776 tracked only a few kinds of jobs. Now, there are hundreds of kinds of jobs, but the new ones are not a significant part of the labor force. Here's the list of jobs ranked by the number of people who perform them. It's a sobering list with the transportation industry at the top. Continuing downward, all of this this work existed in some form 100 years ago, and almost all of them are easy targets for automation. Only when we get to number 33 on the list is there finally something new. Don't think that every barista or white-collar worker need lose their job before things are a problem. The unemployment rate during the Great Depression was 25%. The list above is 45% of the workforce. Just what we've talked about today, the stuff that already works, can push us over that number pretty soon. And given that even in our modern technological wonderland, new kinds of work aren't a significant portion of the economy, this is a big problem. This video isn't about how automation is bad, rather that automation is inevitable. It's a tool to produce abundance for little effort. We need to start thinking now about what to do when large sections of the population are unemployable through no fault of their own. What to do in a future where, for most jobs, humans need not apply.
I think that artificial intelligence absolutely poses a challenge for society and humanity. I think there are various things when we say artificial intelligence. There's artificial general intelligence, which is the idea that there's a singularity coming and that something will become so smart that we won't be able to control it, and it might even decide that human beings are kind of a bad idea and get rid of us. And I think that's a real threat. I think that it's not, in my view, imminent. I think that we have a little bit of time. And I think actually what I'm more concerned about personally is the machine learning. Machine learning systems that we have today have become so powerful and are being introduced into everything from self-driving cars to predictive policing to assisting judges to producing your news feed on Facebook on what you ought to see. And they have a lot of societal impacts, but they're very difficult to audit. They're not like normal software programs where you can just read the code and understand what they do. In fact, even the developers, unless you test them, don't understand exactly, they can't predict exactly what the outcome is going to be. So there are estimates that self-driving cars may reduce traffic accidents by 90%. There are types of diagnostics where machines seem to be faring much better than human beings at diagnosing diseases. There is a possibility that things like parole or bail may be very quickly shown to be better judged by machines. These raise some interesting questions because these are lives at risk and lives that could be saved. As we start to introduce these things, our regulatory frameworks, the way we think about how society will work under these new systems, whether we're talking about jobs or whether we're talking about the law or whether we're talking about technical architecture, all of these things are going to change. At the Media Lab, we use the word anti-disciplinary because we find that the traditional disciplines, both in business and academia, tend to reinforce a specialization, which sort of the cliches, you learn more and more about less and less. And that's important when you're going deep. But when you have a technology like AI that cuts across all of these disciplines in terms of their impact, you need to create this tissue in between. And I worry a little bit that the people who are designing and deploying these systems are computer scientists who are trying to solve the world's problems through computer science, and that the connective tissue between the discipline of machine learning and computer science and the other disciplines like social sciences or law or even philosophy, that those communities aren't really able to talk to each other because the language is so different and there isn't a lot of culture of interaction between those communities. And I think the way we address this is to start creating much more interdisciplinary work. As we were thinking about how we might tackle some of the missing pieces in thinking about where AI should go, I thought about it with various hats. I thought about it with my MacArthur Foundation hat, with my Knight Foundation hat, the Media Lab hat, and just sort of a citizen of the world hat. And I realized that all of the pieces that needed to be at the table weren't in a single institution. You couldn't give all the money to Media Lab, you couldn't give all the money to Berkman Center, you couldn't give all the money to anybody and get all of the different voices that we needed. And not just voices, everybody has a different framework. So the way that the Harvard Law School thinks about the theory of change and thinking through problems is very different than the way that the Media Lab would do it. So I think the key thing, and you can see through the diversity of the different people funding this initiative, as well as the people who are involved in coordinating it, we're hoping to bring both a diversity of geography, a diversity of sort of technology versus law, so field diversity, but also just a fundamental theory of change and at what layer we should intervene. And so I think, the first couple of years we're going to be doing a lot of really interesting experiments, and hopefully by the end of this process we'll have a pretty good idea of several different things that we should set up either as institutions or as funding opportunities. And I think it's important to start having the conversation, not just the conversation, but doing the work around the policy, thinking about how society should be integrated and respond before it's too late. Because I think one of the problems is that once you move past certain points, it's going to be difficult to roll back. And so I think timing-wise, sort of beginning last year and this year is really the key point in bringing others into this process. Because up till now, the computer science was just getting to the point where it was ready to be deployed. Right now, it's sort of just right or almost a little bit too late to get started. So I think the timing is super important.